What if I told you that everything you think you know about the universe might be wrong? Yes, you heard it right. What we perceive as the universe, our very understanding of it, is constantly changing, evolving, and being challenged. This is the story of not just our universe, but of ourselves, of our ceaseless quest to comprehend the cosmos that surrounds us. Our journey today takes us on a trip through time, a fantastic voyage that begins with the earliest humans who, like us, gazed at the night sky in wonder and awe. From the ancient times to the present day, our understanding of the universe has been a journey of discovery and revelation, marked by moments of great insight that have expanded our horizons and shattered our preconceptions. Consider this: there was a time when we believed the Earth was the center of the universe, with the sun, the moon and stars circling around us. A time when the concept of other galaxies was beyond our comprehension. A time when black holes, quasars, and dark matter were mere figments of our imagination. And yet, here we are. Our perspective has shifted, our knowledge has grown, and our understanding of the universe has been transformed. We'll be diving into the minds of the great thinkers and explorers who have shaped our knowledge of the universe. The ancient philosophers, the daring astronomers, the curious scientists, each has played their part in this grand cosmic drama. We'll explore the revolutions in thought that have upended our understanding of the cosmos and the theories that are yet to be proven. So, buckle up, my friends. This isn't just a journey across the stars, it's a journey through time, a journey of discovery, a journey that tells the story of our place in the cosmos and our relentless pursuit of knowledge. Prepare yourself to travel back in time, to when humans first started to look up and wonder. Our journey begins thousands of years ago with the earliest civilizations. These pioneers of humanity, the Babylonians, Egyptians, and Greeks, looked to the heavens with curiosity and awe. They saw the twinkling stars, the waxing and waning moon, and the blazing sun, and they sought to understand. Their observations, though simple, were the first steps in a journey that would span millennia and lead us to our current understanding of the universe. The Babylonians, for instance, were meticulous record keepers. They tracked the movement of celestial bodies, creating the first star catalogs. Their work was so precise that it allowed them to predict lunar and solar eclipses. Though they did not understand the mechanics behind these celestial events, their observations laid a solid foundation. Meanwhile, the Egyptians, with their keen understanding of mathematics and geometry, built monumental structures like the pyramids with astonishing accuracy. They aligned these structures with celestial bodies, revealing their understanding of the constellations and the cyclical nature of celestial events. Then came the Greeks, whose philosophers and mathematicians like Aristotle and Pythagoras pondered the nature of the cosmos. They proposed that Earth was a sphere, contradicting the common belief of a flat Earth. Their theories, though some were incorrect, sparked debate and encouraged critical thinking, pushing humanity one step closer to understanding our place in the universe. These ancient civilizations, in their own ways, contributed to the body of knowledge we now have about the universe. Their observations, calculations, and theories were stepping stones, guiding future generations towards greater discoveries. They observed, they questioned, and they sought to understand, all without the aid of modern technology. Though rudimentary by modern standards, these ancient civilizations set the stage for our understanding of the universe. Their curiosity and determination to understand the world around them, to make sense of the twinkling stars and moving planets, ignited the flame of knowledge that continues to burn brightly in the field of astronomy today. So, as we delve deeper into our cosmic journey, let's remember these early stargazers, for it was they who first opened our eyes to the wonders of the universe. Scene script. Fast forward to the 16th century and enter Nicholas Copernicus. This Polish astronomer dared to go against the grain, challenging the popular geocentric model that had been widely accepted since the days of Aristotle and Ptolemy. Copernicus proposed a radical idea, a heliocentric model where the sun, not the Earth, was at the center of the universe. Picture this: a universe where all the planets, including our Earth, revolve around the sun in circular orbits. This was a monumental shift in thought. It meant we weren't the center of everything. It meant we were just one of many celestial bodies orbiting a star. But this wasn't a change that happened overnight. The heliocentric model was met with resistance, and for good reason. It contradicted religious beliefs and centuries of scientific thought. The idea That we were not the center of the universe was to many a deeply unsettling proposition. However, the heliocentric model began to gain traction. It elegantly explained certain astronomical phenomena that the geocentric model couldn't. For instance, the retrograde motion of planets, where planets appear to move backward in the sky, made sense in the context of a sun-centered universe. The work of scientists that followed, such as Galileo Galilei and Johannes Kepler, further supported Copernicus's model. Kepler, for example, refined the model by suggesting that the planets move in elliptical, not circular orbits. Despite the controversy and the resistance, the heliocentric model ultimately replaced the geocentric model. It gave us a more accurate understanding of our universe, and it laid the groundwork for future astronomical discoveries. Copernicus's model was revolutionary, literally and figuratively, and it forever changed our place in the cosmos. Copernicus took us from a universe where we were the center of attention to one where we are just a small part of a vast and complex cosmic dance. His courage to challenge the status quo and his commitment to scientific inquiry continue to inspire us, even today. The Copernican revolution set the stage for the birth of modern astronomy. In the wake of the Copernican revolution, the 17th century ushered in a new era of astronomical discovery. The introduction of the telescope was a game-changer. Before this, the cosmos was a far-off mystery, but now, the stars were within our grasp. The telescope, first used by Galileo Galilei, allowed us to see further into the universe than ever before. Galileo's work was instrumental in shaping modern astronomy. He didn't just observe the stars and planets, he questioned, he tested, and he discovered. Galileo was the first to see craters on the moon, the phases of Venus, and he even discovered 4 of Jupiter's largest moons. His observations supported the heliocentric model, giving further credence to Copernicus's revolutionary theory. But Galileo's work was only part of the story. Enter Johannes Kepler, a German mathematician and astronomer. Kepler was fascinated by the movement of the planets. His rigorous study led him to formulate 3 laws of planetary motion. The first law stated that planets move in elliptical orbits around the sun. The second law proposed that planets sweep out equal areas in equal times, meaning that they move faster when closer to the sun. His third law established a relationship between the time a planet takes to orbit the sun and its distance from the sun. These laws were groundbreaking. They explained not just how the planets move, but why. Kepler's laws, combined with Galileo's discoveries, significantly expanded our understanding of the universe. They provided a foundation for the laws of physics and laid the groundwork for the scientific revolution and the Age of Enlightenment. The birth of modern astronomy was a pivotal moment in history. It marked the transition from a time when the universe was a distant, mysterious entity to a time when we could reach out and touch the stars. It was a time when humanity realized that we are not just spectators in the cosmos, but active participants. The birth of modern astronomy brought the universe closer to us than ever before. In the early 20th century, a man named Albert Einstein would again revolutionize our understanding of the universe. Picture this. You're on a journey, not just any journey, but a cosmic journey. And at the helm of this journey is a man with wild hair and a twinkle in his eye, Albert Einstein. Einstein, a theoretical physicist, came up with something that would change our perception of the universe forever. He called it the theory of relativity. The theory of relativity, composed of 2 parts, the special and the general relativity, is a bit of a brain twister. Special relativity, proposed in 1905, tells us that space and time are intertwined into a single continuum, known as spacetime. Events that occur at the same time for one observer could occur at different times for another. Then, in 1916, Einstein introduced general relativity, which added gravity into the mix. It suggested that massive objects cause a distortion in spacetime, which is felt as gravity. Your apple falling from the tree? That's because it's following the curves in spacetime caused by Earth's mass. But Einstein's theory was just the beginning. In the late 20s, an astronomer named Edwin Hubble made a startling discovery. He found that galaxies were moving away from us in all directions, implying that the universe was expanding. This was a game changer. It meant that the universe had a beginning and could possibly have an end. Hubble's observations and Einstein's theory of relativity had a cosmic dance, leading to a paradigm shift in cosmology. The universe was no longer static and unchanging, it was dynamic, expanding, and evolving. Einstein and Hubble showed us that the universe was much more bizarre and vast than we ever imagined. They presented a universe that was not just a stage, but a player in the cosmic drama. A universe that was alive and growing. A universe that still has many secrets left to be uncovered. Now we venture into the realms of dark matter, dark energy, and the multiverse. In the grand tapestry of the cosmos, there are threads woven from elusive mysteries that we're just beginning to unravel. Let's start with dark matter. This is a term coined to describe something we can't actually see. It doesn't interact with light like ordinary matter, but we know it's there because of the gravitational effects it has on galaxies. It's like the invisible puppet master pulling the strings of the universe. Then there is dark energy, another puzzling piece of the cosmic puzzle. It's the mysterious force that's causing the universe to expand at an accelerating rate. Scientists discovered it when they found that distant supernovae were moving away from us faster than they should be. It's like an invisible hand constantly pushing galaxies further apart. And then we come to the multiverse. This theory postulates that our universe may not be the only one. There could be countless others, each with their own laws of physics, dimensions, and realities. Imagine a cosmic bubble bath, with each bubble representing a different universe. These are just theories for now, still waiting for concrete evidence. Dark matter and dark energy together make up about 95% of the universe, yet they remain some of the most enigmatic entities in cosmology. The multiverse theory, on the other hand, challenges our very perception of reality and existence. What's exciting is that these theories are constantly evolving. With every new observation, every new piece of data gathered from telescopes, satellites, and particle colliders, we refine our understanding, and the picture of the universe becomes a little clearer. These theories and discoveries show us that we are just beginning to scratch the surface of understanding the universe. The journey to unravel the mysteries of the cosmos is a long one, but with every step we take, we're getting closer to answering the age-old question, what is the nature of the universe? And that, my friends, is a journey worth taking. Our journey through time brings us back to the present day. We've traveled from the very roots of human understanding, where our ancestors looked up at the night sky with wonder, to the Copernican revolution that dramatically shifted our perspective, placing the sun, not the Earth, at the center of our solar system. We've delved into the birth of modern astronomy, where telescopes became our eyes into the cosmos, revealing celestial bodies and phenomena beyond our wildest dreams. Then we grappled with Einstein's theory of relativity and the mind-bending concept of an expanding universe. In our exploration, we've also touched on the cutting-edge theories and discoveries of the present age, from the enigmatic dark matter and dark energy that seem to make up the majority of our universe, to the tantalizing hints of multiverses and the possibility of life beyond our own planet. Yet, despite these leaps and bounds in our understanding, it's humbling to realize that we've only just scratched the surface of what there is to know. The universe in all its vastness and complexity still holds many secrets within its star-studded expanse. We're but tiny specks within it, striving to comprehend its enormity and the fundamental laws that govern it. And therein lies the beauty of our cosmic quest. The universe isn't a puzzle to be solved, but a mystery to be savored. It invites us not to conquer, but to explore. Not to know all, but to revel in the joy of discovery. The universe is like a book with infinite pages. As we turn each page, we encounter new questions that fuel our curiosity and drive us to delve deeper. And with every answer we find, a new query arises, keeping the cycle of discovery alive. As we continue to gaze at the stars, who knows what mysteries the universe will reveal to us next?